60 cell till now. This is our memory cell. What is the benefit of this memory cell? What is the benefit of this memory cell?
Sir, what is this RBL?
RWL. Let us say read word line.
Sir, the write and the read operations are separated.
The write and the read operations are separated. Okay, if I look at it as a single port cell, then you are absolutely right, Ranjit. I will write through word line and I will read through read word line.
Yes, sir.
When I've separated these write and read operations, what is the benefit I have drawn out of it?
It's cell stability, sir.
Yes. See, now earlier what was happening? When I was reading, there was a bump that would appear on BLTI or BLFI. So my read operation, my cell was very susceptible to failure. Now what has happened? I can read and there is no impact on the cell stability. Additional thing, I want to have a very high speed memory. If I would use the regular 60 cell, I would need to have a larger pass gate, which means I will need to have a larger pull down also, which means my area would anyways go up, including load on the bit lines would go up, everything. We saw it's the law of diminishing returns. Remember that? However, now I can size these two additional devices, the read port, independent of sizing of the pull down or independent of any other thing. So my read and write operations are decoupled over here. When I read, there is no noise that I inject onto the internal nodes. So my stability is better. Additionally, what do? Now, since read operation is not even of consequence, I simply size my write port according to the requirements of the write port. According to the requirements of the write operation. So I can actually make a more optimal cell, which is faster also and which is more stable also. Are you able to see this? Now, what happens if I use mux greater than 1 and I'm in a write cycle? What happens then? Does my stability remain high or there is something that happens then, which I do not want?
Sir, when you said that key in this cell while reading, I will not be injecting any noise. So VX not there, sir. But why that I am?
So while reading, you will turn on the RWL?
Yes, sir.
When RWL goes on, what happens to VX? Is it changing?
No, sir.
No, no. So there's no additional noise that is injected onto the system there. When will VX change? When word line is selected. But that is during write cycles only. So now my next question is, if mux is equal to 4 and I select my word line now, then there are 3 other cells in which I am not writing. In these 3 cells, I am not writing, but word line has gotten selected. What happens to the stability? Hello?
सर VX थोड़ा सा चार्ज हो जाएगा.
Yeah, so it means that the cell in which I am writing, that is fine. वहां तो आपके पास पता है what data you want to write. But the other 3 cells which were also selected by the same word line, but you're not writing into them because the mux address is to select this one. These 3 cells are in the read mode only. And they have the same read condition as a regular 60 cell. What this means is that, in a sense, while you have decoupled read and write ports, the stability requirement still is similar. However, your read current can now be completely independently adjusted. So I cell now becomes independent of SNM constraint. If you were to use only MUX1, then I would also say that stability problem is taken care of. But if I am not using MUX1, I am using a higher MUX, then stability problem remains. All that I have achieved through this 80 cell then is I have improved the I cell without impacting stability. Are you able to see this? Any questions? Ranjit?
Sir, when we are using mux greater than 1, then this is even an issue in the normal 60 SRAM server, sir.
Yeah. 60 SRAM cell, so you anyway have to take care of stability. See, I started the discussion on this cell by saying, oh, read write are decoupled, so stability is no longer a concern.
Mm-hmm.
Now I am saying, no, stability remains to be a concern if my mux is greater than 1.
Okay, yes, sir.
Again, numerous papers in academia you will see who forget that there is a mux thing there. They simply say, oh, 80 cell is the panacea, it solves all problems. No, it doesn't. If you have mux greater than 1, it doesn't solve all the problems. You need to do something else.
Yes.
Many academic papers simply ignore that aspect. Okay, so I'm telling you this because I don't want you to fall into those traps.
Sir, can you once again explain this I cell concept that you told?
So, okay, in this particular cell, what determines the cell current?
The pull down in the read network.
Yeah, no, not just the pull down, the stack of the two NMOSes connecting RBL to ground.
Yes, sir.
See, when we were designing the similar stack on the regular 60 cell, we had to ensure that PG was much lesser than PD.
Yes, sir.
So my PG being lesser, even though I am giving area, my current was limited.
Yes.
Over here, I can have both the pass gate and the pull down large enough.
Yes, sir.
So in the same area, I don't need to have any constraint sizing on the pass gate, and therefore I can have more read current.
Yes, sir.
Are you able to see this?
Sir.
Yes, Raghav?
Sir, for example, when I'm reading in the bill, if I note if I have a 0 and I want to read that 0, so I put the read word line as 1. But then how exactly, but I'm not changing the word line to be 1. Then how I'm reading?
Yeah, so no discharge will happen. But if BLFI was 1, then RBL would have discharged. So you have read. See, if BLFI was 1,
Sir?
you take RWL to 1. What happens to RBL?
Oh, it discharges.
It discharges. If BLFI is equal to 0, what happens to RBL?
It doesn't discharge, sir.
So I have distinguished between 0 and 1. Na?
Okay. Right.
What does reading mean? I should be able to tell whether inside the cell there is a 0 or a 1.
Yes.
That I'm able to distinguish on the RBL.
Yes.
Yes. Okay. So is there any new figure of merit that is introduced now? So we already have cell current, we already have stability, we have write margin. Is there anything else that you would want to consider as a designer?
So the mux part?
Mux was already there. but it is not a figure of merit of a memory cell, ना?
Okay, yes, sir.
मक्स तो मेमोरी का फीचर है या मेमोरी का कैरेक्टरिस्टिक है.
Area.
Area was a figure of merit even for a 60 cell. That is not a new
But-
figure of merit here.
Yeah.
So,
Sir,
for example, so in this cell, since my reading and writing decoupled, so to improve my write, I can now increase the pass gate size.
Yeah. But as we just said, na, if mux is greater than 1, then you can't do it because of the stability constraints. You will still need to maintain the beta ratio for the other 3 unselected columns. है ना?
So, your point.
The new figure of merit, is it the read speed?
Read speed or read current, we already had a figure of merit. Na? Cell current, we already had a figure of merit.
Okay.
But yeah, okay. The new figure of merit is also linked to cell current though. Okay. Now consider a case that you are writing. So you're using it as a dual port cell. You're using it as a one read write and one read memory. Do you see this cell can be used like that also? This is a read write port like a regular 60 cell, and this is a read only port. You cannot write through this port. Are you able to see this?
Yes, sir.
So if I am using this as one read write, one read memory, then I could actually be writing on this word line and also reading from this port. Can it happen? I might be writing into this cell and reading this cell. So RWL is also selected and WL is also selected. Yes.
Sir, the lower NMOS of RBL is connected to VX, which is dependent
Yes.
on the write. So
Yes.
can we do it simultaneously, read and write?
Yeah, we can. No, there are two independent ports now. But that is where the new figure of merit comes into picture. If it so happens that this word line is selected, and let us say this was 0. So in that case, my bit RBL was not supposed to discharge. Are you with me? If BLFI was 0, and I selected both word line and read word line, RBL was not supposed to discharge. है ना? Hello?
Yes, sir.
Yes, sir.
Now, if my word line is also selected, then this 0 goes to VX. So this NMOS turns partially on. So there can be some current it can sink. Are you able to see this?
So in this case, I'm trying to write 1 when there is 0, right?
No, I'm not trying to write a 1. I'm trying to write on some other cell. In the same row, some other cell I wanted to write there. This cell, I'm not doing anything. This cell only just turned on.
So why it turned on?
Because the adjacent cell over here, there were 3 other cells now. I wanted to write on this particular cell.
Okay, sir.
Let us say. So the word line is common, it will turn on now.
Yes, sir.
So when the word line is on, then the 0 will go to VX.
So because bit line is BLB is VDD.
Charge to VDD, yes.
Okay.
So what happens? As soon as it goes to VX, this NMOS turns partially on. So there is some new current that is now flowing. So until now, we were only looking at I on and I off. And I said that if it is I off, then this cell is storing a 0. If it is I on, then this cell is storing a 1. That was what I had distinguished till now. Now what we are saying is that there is also another current which is I partially on. which should also be considered as 0. Are you able to see this?
So this discharging
sir.
from RPL when it goes to that is IP partially on.
Yes. Yes.
Okay.
So for that, sir, this lower NMOS, do we have to make it high VT NMOS or something else?
So if you make it a high VT NMOS, then what happens?
It will be sorry, not leakage. If we make it high VT, then it will take more time to turn on. Then the read operation will be
See, if
slow.
you make it high VT, then since this is VX, the IPON may go down a bit.
Yes,
Yes.
sir.
But then do you realize that ION will also reduce?
Yes, sir. Yes, sir. Yes.
So you have to actually see. See, what you were looking at was, I want to distinguish initially between 0 and ION. Now we said, no, there is something which is IPON.
Yes, sir.
So आप इतना सारा margin समझ रहे थे, that margin is not there. Actually, you have to have a sense amplifier which distinguishes between these two. Now you're telling me I will increase the VT of the device. So what could happen? This IPON could go here.
But still the margin is there.
But this could come here.
Okay. Yes, sir.
So my margin could actually reduce.
Yeah, yes, sir.
It may come only here also. I do not know. But it could come here also, na, potentially.
Yes, sir.
Depends on what voltage I am operating at. What is the sizing of these two devices? Depend on so many factors.
Yes, sir. Yes, sir.
So there is no single formula that it has to be HVT. Making it HVT may help. It may not help.
Yes, sir. Understood.
Additionally, you cannot simply make just one device HVT. अभी हमने layout देखा है SRAM cell का. If I make this HVT, this also needs to be made HVT. Otherwise, do you see there is a DRC between HVT and RVT devices? I cannot abut them.
Yes, sir.
So in an SRAM cell, you simply cannot say, oh, this device is low VT. You will see many academic papers simply doing this. Oh, I will just put one device at low VT. No impact on leakage. If you do that, you cannot make the layout. You're not even considering the impact on area then. Okay?
Yeah, yes, sir. Yes, sir.
So we design the cells very carefully. What is happening here? What is this?
Two read and two write.
Two
I'm
read
sorry?
and two write.
Yeah.
Two read and two.
Two read write. Both the ports can do read write. So there would be a different cell which would be two read and two write. This is a two read write cell. Okay, both ports can do read write operation. Then there are two ports. So this enables parallel access to the memory from two different processors. Can you think of the new figures of merit that will come into picture here? Hello? What will be how will you measure the stability over here? What will be the worst case for stability? What will be the worst case for stability?
Word line 2 and word line 1 on at same time.
Yes, both the ports on at the same time. That is the worst case for stability. Is that also the worst case for read current?
So yeah, more current will flow.
What would be the worst case for write operation?
Both word line 1 and word line 2 are on with different values of BLs.
Yes. So we are saying that from one port, I'm simply keeping the precharge on. Okay, the precharge is on, but word line 2 is on. And other port I want to write. So what happens? Over here, there is a pre-charge that continuously supplies charge, which has to be sunk through the write driver. Till now, you are only designing write driver to discharge this node. Now your write driver has to sink this additional charge continuously. Are you able to see this? So this dual port memory cell is a little more complex to design than the single port memory cell. Design and analyze, primarily analyze. Design to ho jayega, but analyzing it is slightly more complex. You have to look at what are the worst cases and then qualify those worst cases. Are you able to see this?
So
Yes.
what exactly was the worst case for the write?
Worst case for the write was that, see, there is a write driver over here. It was designed to sink this current only. But my other port also is on and the pre-charge of the bit line is on. So there is a VDD that is being supplied to this bit line, which goes from the first pass gate and now needs to be discharged through the write driver. So both word line 1 and word line 2 are on, and BL1 is equal to 0 through write driver, and BL2 is VDD through precharge.
Yes.
That would be the worst case for the write. There could be another worst case, which could be that, oh, my which you will realize when you will do that homework that I had given you last week, which could be that, let us say this word line 1 went on, okay, and then word line 2 went on, and BL or BL1 discharged subsequently. So when one of the word line goes on, suppose there was a 0 stored here, what will it do? It will discharge this, and it will discharge this also. Okay. Now you wanted to store a 1 here. Now the bit lines are discharged. The Vx was initially something, but it now falls because the bit lines have discharged. So it is Vx minus. When you will do the solve those equations of write analysis and read analysis, you will see that as the voltage of Vx reduces, what happens? As the voltage of Vx reduces, the writability of the cell would degrade. So that could also be another worst case. This is slightly more complex. You need not bother about it, but I just want you to remain open to other worst cases that could be there in this particular cell because of two ports. Two ports which are asynchronous. One port could turn on before the other port. Okay.
So ideally, when I have two ports, I want to access different bit cells using these ports. Or
yeah, I am accessing different bit cells only, Raghav.
Okay.
Just the adjacent ones.
Yes, sir.
For one, I am addressing address 0, and with the other port, I am addressing address 1. Because it is mux 4, they are appearing in the same row.